Welcome to today's interview with an engineer. I'm here with Rod Macduff, an electronics engineer. And I'm really excited about this, Rod. Rod is going to tell us what it's like being an electronics engineer and all sorts of other things I'm sure you've done in your career. So Rod, over to you. Thank you.
Thanks very much, Kym. I hope I will be able to tell you not just about things that I've done as an electronics engineer, but more general things that I've done. So yes, as Kym said, my name's Rod Macduff. I graduated from Glasgow University in 1977 when the world was a very different place. But obviously Glasgow University is in Scotland, a long tradition of engineering. But at that time, computers were more or less batch processing jobs, and these things here, books, were what we studied from. This is probably one of the key books that I use, not at university, but a bit later. It's the third edition of the Electronic Engineer's Handbook that I drew on heavily. Another book that I drew on was Art of Electronics. I'm sure a lot of you electronics engineers will know this book very well, by Horowitz and Hill. So yes, back then it was a very different world, and the other thing we kept was lab books, and I'll tell you about this lab book a little bit later. Anyway, I graduated in '77 and I went south to London to work for a big electronics engineering company, defense electronics company called Racal. I was also passionate about radio, and I got involved in a defense electronics project, which was the design of the first VHF frequency hopping radio. Now, the Americans in Vietnam got into a lot of bother when the Viet Cong intercepted their radio traffic and then played it back to them when they were in a different area, and they bombed their own troops. So as a consequence of that, they developed frequency hopping so that enemy forces couldn't listen into them. So I was involved in the first project to develop a frequency hopping VHF radio. Anyway, I worked for Racal in the UK for 8 years, and eventually, after a visit to Australia, after a holiday in Australia, I thought, what am I doing in the UK? So with my wife at that time, we emigrated in 1989 to Western Australia, to Perth in Western Australia. And at that time, the internet was really in its nascent stage, and we brought a fax machine with us, and I applied for jobs using the fax machine. Got a job with an excellent company called Poseidon Scientific Instruments, and designed X-band search and rescue transponders for them. I might have a picture of one here. Yes, here we are. On the back of this cover is the search and rescue transponder, which is a marine product, maritime product.
Rod, can I just ask, is that an EPIRB? Is that what that's?
Exactly. It's like an EPIRB,
Okay,
Kym.
okay.
It is very like an EPIRB. There was a thing called the GMDSS, the Global Maritime Distress and Safety System, and it mandated EPIRBs and it also mandated SARTs. They were like two sides of a coin.
Oh, right. Okay, great.
So that was interesting and challenging work, and I would encourage any young engineer, if they get any opportunity to broaden their discipline, to embrace it with both hands, even if it means extra work. I've always found that nothing was wasted when it came to doing extra work. So I then saw a job advertisement in the West Australian newspaper, because that was long before Seek, for chief engineer at Barrett Communications. So I got a job designing shortwave radios. These are the sort of radios that the Royal Flying Doctor Service uses, for Barrett Communications, and that went very well. And later on, after 2.5 years with Barrett Communications, I got talking to some other people in Barrett Communications, and we decided that there was a market for a much smaller portable backpack radio. But at that time, Barrett's weren't keen to adopt it, so we left Barrett's to form our own company, which was called Kym Electronics. That was with Pat McClelland and Liz Natta. My first job at my own company, Kym, was to design the HF90 radio. Initially, that was a commercial shortwave radio with a range of about 1,000 kilometers. We were very fortunate because now, as then, governments of both persuasions and federal and state government offer research and development grants, and we were able to avail ourselves of one of these grants, and that facilitated the development greatly. We were also able to get the tax concession. I think there's currently a 43% tax concession. That was also beneficial. And there was also an export marketing development grant. So we really got a leg up from both the state and the federal government, and I'm still grateful for that. So the radio was developed using tools that were appropriate to the time. Back then we used a thing called Protel Autotrax, which was a fairly primitive computer-based design tool. But a lot of that was done, as I mentioned earlier, a lot of the design was done just in the good old lab book, and that's my very first lab book. It's even on the first pages, it's probably got a little picture of the radio, of how it would turn out, and there we have it, picture of HF50 as it was called then. Marketing team decided 50 was not a good number, so it ended up HF90, and it went from scribbles on a piece of paper and a lot of work on Protel Autotrax to a finished product weighing 1 kilogram.
That's so exciting. Can I pick that up? Can I just feel that?
You can.
That is, so that's 1 kilogram.
It's 1 kilogram.
Okay. Now, who uses radios? Who was that created for?
This radio was designed for quite a broad market. It was designed for Royal Flying Doctor Service. It was designed for four-wheel drivers. There is now a network called the National Four-Wheel Drive Radio Network that provides a mantle of safety over the whole of Australia, and that was the first market, but we always had in mind that this would be an export product, and it was designed with the idea that we could make the radio hop, and that would lead to much increased military sales. And that was in fact a very successful strategy. Just going back briefly to these grants that we're talking about, another thing that was tremendously beneficial was applying for design awards. Now I have to credit Engineers Australia, because we were lucky enough to enter and win both the 1997 and the 2000 Engineering Excellence Awards. And that was a good thing, not just from the point of view of feeling good about ourselves and the kudos and the publicity, but a really good thing is it forces you to examine your own performance, and in submitting the award you reflect on what you've done and some things you could have done better, but it really shines a light on the project, and that was a big plus. So thank you, Engineers Australia. And we also won the West Australian Industry and Export Awards, about 3 or 4 of them. And we won the National Australian Design Award. That's a bit like
wonderful. So do you have to submit applications to these awards, or are you nominated?
Every single one requires a very detailed, analysed award, which addresses lots of things: fitness for purpose, environmental impact, return on investment. These awards have been very carefully constructed to make sure that they apply to all projects and products. I mean, we were up against railway locomotives from the Queensland, I think, Ghanaian company. It was bridges, it was roads, it wasn't just shortwave radios. So the criteria embrace the entire engineering perspective.
Fantastic.
So yeah, the radio did turn out to be a success. We sold it in 120 different countries. And one of the things I focused on when I was in that design phase of the radio was talking to people in the marketplace, and not just the pen pushers in the offices who are procuring it, but I went into the places where the technicians go, where they're repairing the products, and I bought lots of competitive products. I stripped them down, I looked inside them, I analysed what things were good, what things were bad. I talked to the technicians. In many cases in radio workshops, there were radios lying about, obviously in the process of being repaired but not able to be repaired. So I would ask them, why aren't these radios repaired? And they'd give me all sorts of reasons, like, oh well, they need this very expensive custom circuit that comes from England and we can't get it here in Nigeria. And so one of the keystones of the design of this product was it would use generic electronic components that in all these foreign countries you could buy them.
Readily available, yeah.
Precisely. Go to the catalogue, a bit like Amazon, I suppose, nowadays, and procure the necessary repair products. So yeah, the other thing was that the product had to be well designed and easy to repair. Now, I have taken all the screws out, so it should simply open. It's because
Wrong side.
pulling the wrong end. Very good. So yes, you can see it simply slips out. And we've got two printed circuit boards face to face. We've got the receiver board on the back side, which for a 25-year-old product is still fairly sophisticated and quite high packing density. And we've got the power amplifier, a transmitter on the other side. Lots of test points.
I prefer that side, it's more colourful, it's very pretty.
it is more powerful and it's more heavy duty, but this is probably the higher tech side. This looks more like the insides of a computer,
Yeah,
which it is, because after all, that's the computer chip that drives it, and that's more like a steam radio. And so servicing this was as simple as splitting the two boards and soldering whatever needed to be soldered. So we sold well over 15,000 of these radios, some of them military and some of them commercial. And I sold Kym Electronics to a competitor after 15 years of business. And yeah, it's notable that the product, unusual for an electronic product, it had a manufactured life of over 15 years. And if you look at a mobile phone, typically that's a 2-year lifespan.
Absolutely.
So we were really thinking of the long haul.
That's amazing. Fantastic. Well, this is so interesting. It just, I've seen radios before and I've never thought how they work or what goes on behind them. So just having a look at the boards has been really interesting for me. Rod, what are you doing currently?
Well, Kym, I was really fortunate in that fairly recently in October, I was headhunted by the Department of Fire and Emergency Services, WA. They are setting up an emergency communications blackout last-ditch shortwave radio system. Now the idea is that if there's a region of WA where all communications are lost, they'll be able to switch on their emergency shortwave radio system and bring that in to plug the gap while communications are being restored. So in order to develop this, I was recruited as a consultant to optimize their system. So I've actually just submitted my report to them, and we shall see what happens.
That is absolutely incredible. So engineering not only makes people's lives better, it can actually save lives.
It certainly can.
That's amazing.
For the emergency service, it's a vital tool.
That's incredible. Well, in the recent Wooroloo fires, I know that my son lives in the Vines, and he got a text message at 2 o'clock in the morning to say evacuate.
That's right.
So he had to do that. So it's that, you know, those communication means are vital.
They're vital, and of course bushfires can storm through an area and rip out the mobile phone towers and all the VHF towers. So another communication system is necessary.
That's absolutely brilliant. Do you have any advice for our engineers out there? We've got student engineers in all sorts of disciplines, and what advice do you have for them?
Well, I guess the first thing is, as you can probably tell, I regard engineering as a passion. I'm passionate about engineering. It's not a job, it is a calling. So if you get the opportunity to embrace a new skill, take it. Absolutely nothing is wasted. Almost everything I've studied, I have used. Second thing is develop a feel for your discipline. You should get to the stage where you instinctively know the right thing to do to solve a problem, as well as calculating. And you achieve this through immersion and experience. Once you're in the zone, ideas will come to you very quickly. And if you're not getting the experience that you want at work, do night classes or initiate some home projects in order to get that experience. As an electronics engineer, I did lots of home projects. For the electronics people among you, or the software people, program a Raspberry Pi or an Arduino, or write an app, or buy a 3D printer. Set up a home workshop if you're a mechanical engineer. Modify your car. I'm sure you mechanical engineers have lots of projects, potentially home projects you'd be passionate about. Next thing is set your goals and take the steps to achieve them. As I said, awards and grants are a great way of setting yourself tram tracks to ride along, and they tend to stop you from deviating and help you to maintain your focus, because for these awards, for these grants, you have to report back periodically on how the project is going. So that there's nothing like that focusing the mind for the next tranche of money to come along. More generally, I would say, read widely, join a book club, learn a musical instrument, learn a foreign language, and in all these cases, take lessons, take classes. Engineers tend to be introverts, so any activity, learning activity that's also social activity has got to be greatly beneficial to you. I took the Myers-Briggs years ago, and I came out as strongly introverted, but you wouldn't know it now.
I would not have guessed that. No, not at all.
But I'm an introvert who has pushed himself to be an extrovert. So if you're going to succeed in your discipline, it really is a tremendous benefit to do public speaking classes or anything that gets you out there. Another thing I would say, I love YouTube. Watch YouTube, learn lots of stuff from YouTube, see people solving problems, and share. Make your own YouTube, create a wiki. These are the ways to share your experience. So lastly, I would say, don't forget the dictum that less is more. When you're designing, whether it's a bridge, whether it's a railway locomotive or a shortwave radio, keep it simple, and particularly in software. Simple is always more elegant, it's more reliable, and it's easier to use. So yeah, design for a lifetime is what we should do. And as I said, the radio lasted 15 years in production. So make it easy to produce, and finally easy to disassemble at the end of its life. And if you use recyclable materials like aluminium, it can become something else in the future. So Kym, I guess that kind of sums it up.
That is amazing, and I just, yeah, this has been so interesting, and I know the students will find it interesting too. Thank you for taking the time to come and chat with us today. Now, Rod, if any of the students would like to connect with you, are you on LinkedIn or?
I am on LinkedIn.
Oh.
I've got to confess, I updated my LinkedIn profile fairly recently, but I haven't been.
You don't go on it that often.
On it that
so
often.
That's fine.
So I will promise you that after this goes to air, I will pay LinkedIn more attention, because like Seek, it's also a useful tool.
It is, absolutely. Thank you, Rod.
My pleasure.